So in this video, we're going to talk about Descartes' Rule of Signs, which is kind of this like oddball rule that can be helpful. So, okay, to do this, you need a polynomial with real coefficients and a non-zero constant term. So the constant term cannot be zero, it has to be a number, positive or negative. And you want the terms in descending order. So Descartes' Rule of Signs says two things. I really think of it as like two different tests with some slightly complicated like ways to interpret the results. So the first test is, so then it says the number of positive real zeros of f either equals the number of variations in sign for the coefficients of f of x, or it is less than the number by a positive even integer. Okay, so what this is talking about is, so positive real zeros. So positive numbers that make f of x equal 0, that is what this is talking about. And the test that you perform is you look at the sign changes for f of x. Now, this last part of is less than that number by a positive even integer, this is talking about possibilities. So like what this whole test is talking about is ways to determine different possible combinations of zeros. So I'm going to show you how all this works in a second, but I just want to kind of give you a game plan here. So next, we have the number of negative real zeros of f either equals the number of variations in sign for the coefficients of f of negative x, or it is less than that number by a positive even integer. Okay, so now we're talking about negative numbers that make the polynomial equal 0, and the test that you're going to perform for that is f of negative x. And then once again, this last part here is talking about different combinations. So that's kind of tricky, so I'll show you how to interpret that. Okay, so what we're going to do is we're going to determine the number of different positive, negative, and non-real zeros with the following examples. Okay, so I have this polynomial, and so we've already got it in terms of f of x. So this is already set up to do that first test. And so remember, this is the test to help us determine the possible number of positive real zeros, okay? So what I'm going to do is I'm going to count sign changes. So this is positive and this is positive, so no sign change, right? But then from here to here, now this is one sign change. Then I go from negative to positive, that's a second sign change, and then I go from positive to negative, so that's a third sign change. Third sign change. Third sign change. That is like a tongue twister. Okay. Anyways, so let's just say for now, my positives, maybe I'll just note that here. So my positives are going to be at 3. Okay, so that is the maximum number of possible positive real zeros. Okay, so now the second test. So this one, I plug in negative x, and so what you're doing here is you're just determining what happens to the signs of this when I plug in negative x. And I'm running out of room, so if I go ahead and I evaluate this, this will equal, so negative x to the 5th becomes negative, so this becomes negative 3x to the 5th. Negative x to the 4th stays positive, right, because it's an even exponent, so this will be 4x to the 4th. Negative, so this negative x to the 3rd is negative, and then this is another negative, so the two negatives cancel out, and this becomes plus x to the 3rd. Then this is minus 2x minus 1. Okay, so that's the second test, and now we do the same thing. I count sign changes. So notice from here to here, that's one sign change, and then I have no sign changes until I get to here. So this goes 1, 2, and then no sign changes. Okay, so for my maximum number of negative zeros, negative real zeros, that's going to be 2. So I want to point something out. Notice I could have up to 3 positive real zeros and 2 negative real zeros. That foots to the maximum number of zeros for this, right? So this is a degree 5 polynomial, so we'll have at most 5 zeros. we're not done. Now I'm going to show you the weird part of this rule. So let me clear some space. So what I want to do now is I'm going to make a table of possibilities. So this is going to be a table showing the possibilities of positive real zeros, of negative real zeros, and then of non-real zeros. So the thing to remember with this is all about possibilities. So when we first calculated this, this was 3 and 2. So 3 and 2, that would be all the zeros if this were the case. So there would be 0 non-real. So here's the thing you want to wrap your head around. This is talking about the maximum number of possible zeros. So the maximum number of possible positive real zeros is 3, and the maximum number of negative real zeros is 2. But this doesn't have to be what it is. You could end up having some non-real zeros. So what that means is that you could end up taking away from this column some of the zeros and putting them into the non-real zeros. Now, non-real zeros, remember they come in complex conjugates. So if I had, let's say that 2 of these were actually non-real. So instead of having 3 positive real zeros, I only have 1 because 2 of those went to non-real. That's a possibility. So when this says that it could be less than that number by a positive even integer, that's what this is getting at. It's basically saying to transfer in sets of 2 some of the zeros here into the non-real column. And so what you want to do now is you want to exhaust all the possible combinations of how to do this. So I transferred 2 of the non-real zeros from here to here. Now let's say that I leave the positive column alone, and now I'm going to mess with the negative column. So if I try to deduct 2 of the non-real zeros, or 2 non-real zeros from here, that leaves me with 0. 0 negative zeros or real zeros. So you see how I'm kind of playing with these combinations? Now I want to take from both of these columns. I want to take 2 from here and 2 from here. So what I'm going to do is I'm going to take, this is going to be 1, this is going to be 0, and this is going to be 4. So I want to point something out with this. So like I said, this is the maximum number of possible real zeros that we could have. And then we explore different combinations of non-real zeros with the understanding that these come in complex conjugates. Now notice that each line adds up to 5. Why does it add up to 5? Because it's a degree 5 polynomial. So each line has to add up to that degree, and then each column you decrease it in factors of 2. Okay, so let's do just a couple more of these because I feel like this always messes with people's heads. So let's try another one. Okay, so now I have this degree 6 polynomial, x to the 6th plus x to the 5th minus x to the 4th plus x to the 3rd plus x squared minus x plus 1. Okay, so the first thing I want you to do, I want to like work this out with you. So I want you to determine right now with how this is written, what are the number of sign changes and what does that mean? So maybe pause here to think about it and then hit play when you think you've got an idea. Okay, so when I look at this, so positive, positive, no sign change, and then I go from positive to negative. So there's 1 sign change. Then I go from negative to positive, so that's 2 sign changes. Positive, positive, no sign change, and then here's another sign change. And then here's 1 more. Okay, so what this means is that the number of possible positive real zeros for this is 4 at most, okay? So now we're going to calculate the other test, f of negative x. Again, I think you should pause here and try this on your own just to wrap your head around it and hit play when you're ready. Okay, so if I plug in negative x into all of this, let's see, minus Okay, so I'm kind of running out of room here, but let's see. So this will simplify to x to the 6th minus x to the 5th minus x to the 4th minus x cubed plus x squared plus x plus 1. Okay, so now when I count my sign changes, there's one change here and one change here, so there's 2. Now that should not be surprising actually, because this is a degree 6 polynomial, so I would hope that the combination of sign changes here, they should add to the degree of the polynomial. Okay, so now for the tricky part. Let's set up the table. So I'm going to go ahead and clear some space, and I would suggest you set up the table, and I will set up mine as well. Okay, so I'll set up the table. Okay, so here's my table with just what we found, okay? Now the thing to keep in mind, the thing to keep in your brain, is this is just talking about possibilities. It's not that we're guaranteed to have 4 positive zeros and 2 negative real zeros. It's just a possibility. So now what we have to do is we have to cycle through, what if I transferred 2 from either one of these columns into the non-real? So you want to cycle through all the possible combinations of them. So I would recommend, if you watched the last example and you were like, what? Just try it for a second. Like, just give yourself a second to try to replicate what we did in the last example and then hit play. And I think this will make a little bit more sense to you if you at least try a little bit. Okay, so what I'm going to do is I'm going to start with the positive column, and I'm just going to go through and start transferring sets of 2 zeros from here into the non-real. So if I take 2 zeros from the positive column, that's going to decrease this to 2 zeros left. So I moved 2 into the non-real column. I'm not messing with the negative column right now, right? Now, I could do this again. I could also take these 2 zeros and transfer them into the non-real column. So that would leave me with no positive real zeros and 4 non-real zeros. I haven't messed with the negative column yet. So now I have exhausted all the possibilities for transferring some of the zeros here into the non-real column. So now I'm going to reset this column and do it to the negative column. So now, instead of having 2 negative real zeros, I'm going to transfer those into the non-real column. And now what I need to do is I now need to do both of these at the same time. So if I had 2, so if I transferred, let's see if I have enough room. If I transferred 2 of my zeros in the positive column and 2 in the negative column, that would bring me to 4. And then what if all of my zeros are not real? They're just entirely non-real. So this is something we've talked about, that a even degree polynomial could have entirely non-real zeros. And this is just a way of like visualizing how that could happen. So all of these lines are just talking about possible ways that you could like end up with your zeros as you're solving this. So what this means is you couldn't have, like if you understood Descartes' Rule of Signs and you were thinking about it and you just found one negative real zero, you would know that's incorrect. You have to find 2 or none. Those are the possibilities for like negative zeros, negative real zeros. Okay. So let's just try one more of these. Okay, and so for this last one, I want to encourage you to try this one totally on your own. The one thing I'll point out is, so you notice we go from x to the 5th to x to the 3rd to x squared. So don't worry about the missing x descending order, x to the 4th, x squared, all that. Don't worry about it. You can just forge ahead and just count the sign changes that you see. I suggest you try this one totally on your own and then hit play when you think you've got it. Okay, so let's see. I have 2 different sign changes. So now I will just go ahead and I'm just going to show you what the result of plugging in negative x is. So this will become negative since it has an odd exponent. This will become positive again since it has an odd exponent. So basically when you have an odd exponent, the sign will flip. Okay, so if we count sign changes this way, I've got 1, 2, 3 sign changes. Okay, so I've got a maximum of 2 positive real zeros and a maximum of 3 negative real zeros. So now we need to make the chart, so I'll clear some space. And I've just set up the chart with that first line of the maximum number of possibilities, and from here we just need to cycle through other possibilities now. So if I were to take two away from here and put it into the non-real column, I would then have 0 positive real zeros, but 2 non-real, and then I didn't do anything to the negative column. Now I'll reset the positive column and take 2 away from the, take 2 away from the negative real zeros column and transfer them into the non-real, and now I need to do both columns together. So this would be 0, 1, and 4. So yeah, that could be a little confusing sometimes. So I think the thing to remember is that this is the maximum number of possibilities. Each line has to add up to this degree, and then you're cycling through, really taking away like 2 at a time from each column until you've gotten it to like the minimum number and transferring it into here. So I would do one column, then the other, and then do the possibilities together. So you can kind of think of it as a pattern in some ways. Okay, and so that brings us to the end of this video. So you have any questions or comments, feel free to leave them on the video. And otherwise, I will catch you guys in another one. Thanks for watching.